All right. Everybody have a good lunch? Yay. Y'all filled up with good Polish food like Thai chicken? Yeah? Who's ready for a nap? Good, because I'm going to be talking about cloud, and that will put you straight to sleep. Go to sleep. See, because here's the thing. If you all take a nap, then I get to take a nap as well. So, who really wants to hear about cloud? Damn it. All right. Let's talk about cloud for a little bit. Part of what I want to do with this presentation is I want to kind of go over some of the concepts behind cloud, because I think this is one of those terms that everybody loves to apply in whatever way they see fit. It's a ridiculously vague term, and so there needs to be a certain amount of discussion, of agreement in terms of the terms that we're using in order for us to have any sort of meaningful progress in this space. One of the things, of course, this being a developer show, I'm here to talk about the developer cloud. So if you have any questions about your Apple iCloud, I suggest you talk to Ken Sipe right there. He'll be more than happy to answer any questions you have about iCloud, because secretly he works at the Mac Genius Bar. Seriously, he does. It's like, hey, I need my Mac fixed, I go to Ken. All right. There are a couple of core terms that we want to capture as part of what the industry as a whole has decided in terms of cloud. But one of the key things to understand about cloud is it's really all about this fundamental idea. And there's this great phrase from the Polish. I don't know the original Polish version of it, but translated it means, not my circus, not my monkeys. You guys familiar with this phrase, or were people lying to me when they said that's Polish? It is. Okay, cool. Yay. Yay. It is Polish. Awesome. The whole point is, it's not your problem. It's not your thing to worry about. You don't have to worry about acquiring the hardware. You don't have to worry about upgrading the software. You don't have to worry about troubleshooting disk packs. It's literally not your problem. It's not your concern. And so therefore, we can just be developers, and anything that doesn't encompass development, yeah, push it to the cloud. We don't care anymore. As a matter of fact, there are even companies now, a friend of mine works at, that will handle the whole issue of calling people in the middle of the night when shit breaks. It's a company called PagerDuty out of San Francisco. They are literally making a business out of pissing off developers. I mean, think about that. That's got to be the best business model ever. Let me see. Calling developers at 2 in the morning to tell them that their code broke, and they're paying us for the privilege. Gotta love that. The other thing, though, that we have to address is the fact that part of the reason that cloud works is because of this concept called economies of scale. If you want to stand up a data center, there's a lot of fixed cost overhead that you have to put into place. You got to put in the Halon fire extinguisher system. You got to have somebody to monitor the machines, make sure power is there, etc. If you were just spinning up a data center for like 1 or 2 servers, it doesn't make sense, because you have to hire people to be there 24/7. And one person can watch more than one machine. At least we assume they can watch. I mean, you got to think about this system administrator. His entire 8-hour shift consists of, it's not broke yet. Still ain't broke, right? He can do that for more than a couple of machines at a time. So we actually get some benefit by putting all of these machines into one place, and this is referred to specifically as economies of scale. Cloud lets us take advantage of that so that each incremental machine, up to a certain point, becomes cheaper to own and operate and manage and monitor and so forth. A couple of the other concepts that are common to cloud, one of the best reasons to do cloud anything is to fire people. Seriously. You no longer have to worry about buying hardware, so you don't have to have a department of people, procurement, who are responsible for buying hardware. You can fire them. You don't have to worry about operating system upgrades. You don't have to worry about database version upgrades. So you can fire all of your system administrators. At least that was kind of how it was first laid out, particularly with some of the more vertical as a service offerings, right? When we started talking about email as a service, Gmail and Outlook 365 and so forth. The whole point there was you can fire your email administrator. You can fire your Exchange administrator. You don't have to pay for them anymore. We'll just let Microsoft administer your email. You guys are okay with that, right? Not Microsoft, Google, of course. Google, of course, is the company that does no evil. The fact that they read your email and use that as a way to suggest certain ads to you, that's not evil, that's just capitalism. We're okay with that, right? You guys are very quiet. You're like, wow, this is real wisdom. Google, evil, capitalism. I'm writing all this down. The other thing, though, that cloud gives us is the opportunity to get more easily. When I want a new server, literally all I have to do is walk into the AWS administrative console and say, yeah, spin me up another one of those. And AWS says, okay, boom, now you have one. Off you go. Within a span of 30 seconds, you now have a new server with potentially a new DNS entry and the whole 9 yards ready to go and wait for you. I remember, and this was probably not more than 5 or 10 years ago, meeting with the CTO of a very, very big, powerful accounting firm, and he was telling me that part of the reason why they wanted to move a lot of their systems to the cloud is because it takes his procurement department, and I'm not joking about this, it takes them 3 months to buy a server. 3 months to buy something that I can go wander off to Dell.com and place an order for. And it's like, what? Never mind. I don't need to know. It takes them 3 months. You want it to be less than 3 minutes. This makes sense. Cloud gives us that. Again, because economies of scale, Microsoft, Google, Amazon, they've already got the servers. It's not like every machine is in use right now. They've actually got a whole collection of racks of machines just sitting there idle, waiting for you to have some brilliant inspiration and reserve a domain name and buy some time on a machine that you'll never actually use. So, that ability to acquire more and more quickly is super, super critical. And the best part is, I don't have to do anything once I've got it. Again, not my circus, not my monkeys. That instance will just keep running infinitely as long as I keep paying the bills. Now, will it actually be the same exact server the whole time? Nah, they'll probably move it around. They'll serialize it. They'll move it to a different server, rehydrate it over there. And for the most part, you'll neither know nor care whether the actual piece of machinery you're running on is the same one you were running on the day before. As long as it obeys all of the service level contracts we have, that's good enough. Let's talk about a couple of common terms to make sure that we're all on the same page. By the way, these are my terms, or at least my interpretation of these terms. If you don't like these terms or if you disagree with these terms, first of all, GeeCON would love to have you come speak next year and we can hear your definitions. The other thing is, frankly, if you disagree with me too much, remember, I'm American, we will bomb you. Okay? So dirt. Dirt is actually important because dirt will actually determine where the hardware rests and therefore what laws it is subject to. This is actually quite critical for a number of situations that are emerging today because, quick show of hands, how many of you trust the US government? There is one hand back there in the back and everybody else around him is going, shut up, shut up, shut up. Yeah. Because the thing of it is, the US government has demonstrated that they are more than willing to work with technology companies to get data that they think might be important as part of an investigation someday. And whether you agree or disagree with that, your customers may have a very, very different opinion. So, for example, if you are doing any work for German companies around their financials, all of that data must rest inside of German borders. The dirt still matters in many cases. This is part of the reason why so many of the various cloud companies are spinning up so many cloud centers in areas that are not too far away from another cloud center, because dirt matters, except when it doesn't. The second thing, hardware, actual computing machinery, I don't think there's any real debate about that. Commodity, this is actually an economics term. When I have a market that is a commodity market, it means I don't really care who's X or who's Y that I'm using. So, for example, when you go to refill your car with gas, do you really care whether it's brand X or brand Y? Usually you just go for whatever's cheapest or most convenient. The cloud is quickly turning into a commodity play, which is part of the reason why we keep seeing the big three, Amazon, Microsoft, and Google, readjusting their pricing structures on a fairly rapid basis. They're starting to realize that price is going to be one of the key distinctions. The other thing that they're trying to do in order to avoid being a commodity market is convince you that there's a difference. And this is not new. If you've ever flown on a commercial airline, you know that each one of those airlines has a frequent flyer program. Me, I'm a Delta whore. I have 1 million miles on Delta. I will choose to fly on Delta because they take care of me. They do lots of good things for me. They let me board early. They bring me nice food. They let me upgrade into the front. They let me do a lot of things that other airlines won't. That is a deliberate and conscious ploy to make me differentiate between a flight on Delta or any of its associated partners versus a flight on something else. So the cloud is turning into a commodity, and the cloud vendors are trying very, very hard to stop that in a variety of ways, usually by trying to release new features. We'll talk a little bit more about that later. Elasticity is the ability to scale up and down. How quickly can I turn things on? How quickly can I turn them off? That matters too. And then as a service. This is the classic phrase that we're attaching to everything these days. It means that it's not directly under your control, but it's something you can take advantage of. And right now, it's everything as a service. I kid you not, I heard of a service that exists in New York. It is Mom as a Service. If you are sick and you are not feeling well, you can use this app, and this lovely elderly lady will show up at your door with chicken soup, and she will tuck you into bed, and she will read you stories, and then when you're feeling better, kick her out. Mom as a Service. Gotta love it. I heard that they were going to do Dad as a Service, but they couldn't figure out what dads actually do inside the house. So anyway, there are a couple of different models to think about with respect to the cloud. First off, the public cloud, that's the one that most of the time that we talk about, right? This is where you're running on the cloud provider's hardware, on the cloud provider's dirt. Frequently, this is a model that's a shared tenancy model. That's your classic AWS, Azure, Google Cloud Platform, et cetera. You usually do not have your own physical hardware. There's no one-to-one fidelity in that model unless you deliberately choose to pay extra for it. There's also a growing amount of community cloud. Some organization will actually pay for cloud, and then you, being a part of that community, will then be able to participate in that cloud. There are some nonprofit organizations and some other folks that are actually pursuing this. And then there's private cloud. This is where you actually make use of various cloud software features to give you some of that elasticity, but it's the cloud software running on your hardware, running on your dirt. This helps address some of the issues that people have with privacy and security concerns while still letting us leverage some of the benefits of cloud. There's the virtual private cloud, which says you're technically in the public cloud, but this segment of, this smaller section of, is private to you. It's owned by you. Nobody else can be on that except what you put there. There's hybrid cloud, which is to say we combine some of the benefits of public and private. So, for example, if you want to have, you currently have run at about 1,000 transactions a second, except for spike periods where you may go up to 1,500 transactions per second. You can actually combine the two where you're running the 1,000 transactions on a private cloud, but when that spike occurs, you spill over into the public cloud to deal with that additional load. And then when the load drops off, you just drop back to running everything on the private cloud. There are a couple of companies, in particular big companies, Fortune 500s and so forth, that are experimenting very heavily with that. Co-location is an old model, your hardware, their dirt, the end. And then lastly, there's this notion of the vendor platform. Salesforce is the perfect example of this, where you are building code to their platform, and where it runs, how it runs, you don't really care because you're a developer. You let them deal with everything else. So Force.com, for example, is the best example of a vendor platform. Google, Microsoft, Amazon, they're all looking to develop one of these themselves as well, so that we can, take more of your money and have you more tightly coupled to what we do, says the various cloud vendors. Platform as a service, infrastructure as a service, software as a service, lots of as a service, right? Depending upon the particular scope. Platform as a service, and again, this is going to be where different people will have different definitions of these terms. To me, the platform is the hardware in the OS. Infrastructure is any of the things that run on top of the OS, compute, storage, networking, et cetera. And then software as a service is any usable bit of software that happens to be running on a cloud somewhere. We're also starting to see a growing number of verticals in the cloud. So if you're building an application today, and you say, I need a login page, turns out there's a fair amount of work that goes along with that. You have to manage passwords, you have to encrypt the passwords, you have to let people change their passwords, you have to make sure that when they forgot their password, you have to make sure that we erase their password and send them a link to a page that is a one-time link that is only good for a couple of hours. How many of you are really excited at the thought of building that infrastructure? No hands go up. That's great because there are verticals that will do this for you. Auth0 is one, Okta is another. There are a few more that are waiting in the wings, but those two are the two big ones. We're starting to see this notion of, can I carve part of your application out and hold that up as a standalone service that you can consume? Database as a service is one of the most popular ones here, where if I want a Mongo instance in the cloud, I can just go over to mlab.com and spin one up. And now it's available and it's running, and it's not in the same place as the code that would be accessing the data. So there's some problems there. But if you just want a Mongo instance in the cloud, bang, 30 seconds later, you've got one. That vertical is becoming a very, very popular thing for a lot of the cloud vendors moving forward. In terms of the services that cloud offers, compute, storage, communications, how do we deal with some of the actual communication that's going on, messaging standards and so forth. Networking is managing the physical layers of the networks, VPNs and VPCs and other three-letter acronyms, take your pick. Acquisition, how do I acquire new hardware, new software? Analytics, people actually spinning up instances of things to watch my instances of things and look for any trends, look for any patterns, use that data as the entry point to trying to detect when I'm under attack, for example. Deployment, management, and then usually each of the vendors will have something that's more specific around mobile because, surprise, not surprising, a lot of cloud is used as the back end for mobile apps. Cool. So now we've got our terminology out of the way. Couple of things to think about when you start thinking about the cloud. What is it specifically to you? What of all of this that I have rattled off actually matters to you? Because remember, in the very earliest days of cloud, the discussion was really around virtualization. How do I lift and shift? How do I take my existing applications off of our hardware and our dirt and put it up into somebody else's hardware on somebody else's dirt? That, for a lot of folks, was really what cloud was about. And this was when VMware was very, very big in the whole cloud play. They still are, but we've kind of nuanced our thinking a little bit to say, well, yeah, that's one aspect. Virtualization is one aspect of cloud. But what we might want to do is we might want to actually rethink the entire architecture of how we build applications, which is ultimately culminating in what we now call serverless. Where, yes, folks, there is still a server involved. I don't know that anybody's ever tried to assert that there isn't, but it's mostly a notion of how do I think about, what's the granularity at which I think about the code? Am I thinking about it as a single function? Am I thinking about it as a component? Or am I thinking about it as a Tomcat instance that has all the code already established within it? What does the cloud mean to you? What exactly are you looking to get out of it? Because let me be clear, when somebody up here just says, cloud makes things go faster, that's not actually true. I mean, in a lot of respects, the development doesn't go any faster because unless you're developing in the cloud, like you're actually running your IDE on a server somewhere in Virginia, which means now from here in Krakow, every keystroke has to be transmitted across the Atlantic and back, and that's not faster, folks. That's actually slower. What exactly does this net you? What exactly are you looking for out of this whole move to the cloud? Because one of the things that frequently gets lost in all of this discussion about cloud is that the fallacies of distributed computing, these mistakes that everybody makes with respect to distributed systems, the idea that transport cost is zero, that the network is reliable, that the network is secure, that there is only one administrator. These 8 fallacies, which have been around for 20, 30 years, they don't go away. Nothing about cloud makes those issues go away. So you still have to deal with all of those problems that are occurring inside of a cloud instance or instances, particularly combined with the fact that now you don't even know what the topology is. Before, when we were spinning this up on our own hardware, on our own dirt, we knew that the app server and the database were going to be talking to each other a lot, so we could make sure that the two of them sat on the same physical box. When you get into the cloud world, you don't always get that choice. And now, if your app server is resting in Virginia and your database is resting in Iceland, that's a lot of communication that's happening over a very long way. And not surprising, the performance of your app is going to be terrible. This is what happened to a lot of the early lift and shift movement is people thought, hey, yeah, if I put it in the cloud, it will just go faster. And in fact, it went slower and consumed more machine resources rather than less. That was not a win for a lot of companies. Fundamentally, any given cloud application is going to be a two-dimensional axis of two nodes on each axis. Is it single tenant or is it multi-tenant? Is it single instance or is it multi-instance? Tenant means how many do I have running on this given machine. Instance means how many instances. All right. Can you hear me now? All right, good. All right. So part of what we want to talk about in terms of when you move to the cloud is your move going to be in a multi-tenant fashion? Are you going to let other applications run on the same machine on which your code runs? Or do you have concerns about that? Because technically, if you have some data and it's multi-tenanted, there may be, and the cloud vendors will swear up and down that there isn't, and there isn't up until somebody discovers one. There may be a way for somebody else to drop through a trapdoor and discover your data. And that actually concerns a great number of people, particularly if you're a bank or if you're dealing with privacy information, GDPR related, et cetera, et cetera, et cetera. So multi-tenant will be out for a certain number of applications, which means that now half of all of the models that we're talking about are no longer available to you. So part of what you want to be clear on is what is the tendency of your application when you move to the cloud? What can you accept? But also, how many instances of this do you expect to run? Because as soon as you go to a second or more instance, a lot of your classic assumptions about how your application can be architected will no longer hold. You can't do an in-memory cache of anything anymore because now you have to do cache propagation, and if we change the cache on one instance, we have to make sure we push that out to all the other instances, which usually loses whatever performance benefit that memory cache was giving you. So part of what we think about when we talk about cloud is the resource elasticity. How quickly can we spin servers up? The part that nobody ever talks to you about is how quickly can we spin them back down? Because this has bitten a number of companies very solidly. There is a story, for example, in the early days of Amazon. I live in Seattle. A lot of the early cloud stuff was developed for startups in the Seattle area. We were kind of their guinea pigs in a lot of ways. There's a story, I don't know names or anything, so I don't know if this is true, but a startup was deciding that they were getting ready to do some performance load testing, and so they wanted to spin up about 10,000 small micro instances on Amazon and have them run a script that would pound the hell out of the startup server. So they turned on 10,000 micro instances, and they had them run for about 24 hours, and the server held up, and everybody said, yay, winning, success, and went home. And at the end of the month, they received a bill from Amazon to the tune of about $2 million. And the startup said, that's kind of funny. And Amazon said, yeah, so you're going to pay it, right? And the startup said, that's even funnier. And Amazon said, no, it's not. And yeah, they had to sit down and negotiate how this was going to work out because no startup has $2 million just laying around, particularly if it's an early stage startup. Turning things off is every bit as important as turning them on. And so how exactly does this cloud provider manage to connect you in such a way that you can see when these instances are still on. Amazon and Azure and Google Cloud, they now all have frequent little checkbox, right? Azure will send you an email every month saying, hey, check your billing, check your billing, check your billing. Amazon will let you set credit card limits that once you hit that limit, they will not bill you further unless they have specific authorization, and so on and so on and so on. Because this wasn't a unique story. This wasn't an outlier. This ran a number of companies into a number of severe financial problems. Now, one of the things that we also have to think about is the fact that as much as the world is growing closer, as they say, it's still physically a long way to go from Seattle to Krakow. It's 9 hours in terms of different time zones. It's roughly about 8,000 aerial miles, not even counting time spent layover in airports and so forth. And unfortunately, even though it's much, much faster to do this over a wire, it's still slow. Proportionally, it's still much slower to send something from Seattle to Krakow than it is from Seattle to Salt Lake City. So one of the things we want to think about is, how do we keep the data and the processors close to our users, close to the users that we are actually working with? And this is where we get into the regionalization of servers. Now, to a certain degree, you may say, I don't care. Right? If you're a startup and you are just serving the country of Poland, hey, spinning up a server in Krakow is plenty good, or spinning it up in Warsaw, right? You may even, want to spin it up in St. Petersburg, because relatively that's not too far away, or Berlin, or somewhere in the Swiss Republic. Any of these doesn't really matter. But when you start serving more clients worldwide, having all of your customers in the US have to negotiate a server in Krakow is definitely going to create a performance inhibition that will stop them from using your system for any length of time. The other thing about your customers to realize, though, is that your customers are not your cloud provider's customers. You are the cloud provider customer. And so what you may want to set up in terms of a service level agreement, if you tell your customers, we will be available 99.999% of the time, you'd best make sure that the cloud provider agrees to that. Because if for whatever reason the cloud provider goes down, and yes, they do go down, they may go down less regularly than your own servers do, but they still do go down. What's the order in which your services will come back up? Will they bring them up in a discernible order? Will you have to somehow deal with situations where your compute might be running without storage, or your storage might be running without compute? Will that screw up things for you? Will that screw up your architecture in some way? Will that create a security vulnerability? Et cetera, et cetera. All of these are considerations that you have to take in mind, because your customers have an agreement with you, not with your cloud provider, and your cloud provider has an agreement with you, and if you are not taking great care to make sure that those two line up and overlap in some fashion, you are likely to get burned in some way at some point. When you own the server, recoverability is your problem and your prerogative. You get to decide what services come up and what services don't. You may say, you know what, we can live without email for a couple of days. Just make sure we get the app up and running. Amazon would happily burn their email servers for a day if it would mean a day less downtime for the actual web app that sells people stuff, because one of these makes people money and the other one doesn't. They get to control the order in which those things come back. When you're in the cloud, not my circus, not my monkeys means you really don't get to tell the monkeys where to stand. You have to rely on your cloud vendor to let them decide what order those services are going to come back, or you have to work out, possibly paying extra money if necessary, what order those services will come back, or what degree of reliability they will offer in terms of failover. Just spin it up on another machine. I don't care if it's the same one. I don't care if it's in the same region. One of the other things that frequently developers don't take into account is that cloud apps are actually a different line on the ledger sheet than an application that's running inside your own private data center. This is something that a lot of people at large companies get frustrated with because the large company doesn't see really this need to move into the cloud. We already have a data center. We already have spent all this money on the data center, and we see no reason why we should throw all of that away. That's a sunk cost. But more importantly, cloud spend is often a capital expenditure. Whereas if you just hire some system administrators to take a look at your data center every once in a while and make sure everything is still running, that's actually an operational expenditure. And so these actually come out of different parts of the budget. Now you say, dude, it's still money. It's still money out of the company. It's an expense. What difference does it make? And thus proving that you are not an accountant. Because accountants and CFOs, they really care about that. And as a matter of fact, that factors very, very heavily into their budgetary planning each year. How much capital expenditure are we going to have? How much operational expenditure are we going to have? Because we actually get tax breaks and we get incentives and we get all these other things that occur based on whether it's one or the other and what category it's in and so on and so forth. So that actually makes a big difference in some of the cloud discussion. Blobs and tables, yeah, a lot of this is just how do we structure our data, where do we store it? A lot of this will be difference between, hey, I just want to have data accessible to me as I run the app versus reporting. By the way, if you ever want to run a report on a production database, please go out into the street and wait for a bus to hit you. You never, 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 never want to do reporting on an actual live production database. The performance hit is generally not worth it. You shunt that stuff off to a second database, which can be denormalized to make it easier to do your reports. And you were planning on testing, right? We all agree that testing is a good thing, going like this, yes? Yes. Yep, everybody's asleep. Awesome. How exactly do you unit test something in the cloud? Is the cloud a unit? I mean, according to the actual definition of unit testing, you don't. You test what's running locally. You test that single action, that single piece of work that's going on. That's what you unit test, and then you just assume that will all work when you plug it all together and throw it over the wall into the cloud, right? We don't have to do any actual real testing in the cloud. Oh, yeah, we probably should do integration testing of some form, which now means that you, in order to be a true integration test, you really need to spin up at least 2 environments. One for the actual production environment and one that is identical so that you can do your testing because you want to make sure that your configurations are the same between those 2. Yeah, I know. You've automated your entire DevOps pipeline. It flows magically all the way into production, except for most companies it doesn't. It flows magically into test because management, CEOs, CTOs, marketing folks, they want to actually have some control over when those releases actually occur. And suddenly now there's a configuration difference between test and production. And I guarantee you it's just a matter of time before that becomes an issue of production that we have to roll back and fix in some fashion because, oh, we thought we upgraded that in production, but it turns out we didn't. So, and if you want to deploy to the cloud, yeah, it's a little bit different than doing it to your own server, most notably that you don't actually get to see the server. But when I deploy, do I need to restart the application? Do I need to re-provision those instances? Do I need to reconfigure them? If my application is a little bit bigger, does it need a little bit more memory? Do we need to actually grow the instance? By the way, how will you know whether or not you need to grow this? You got to have some sort of developer level monitoring to know that you actually have enough room, memory, disk, etc., for your application to grow. There are also going to be changes in the surrounding environment. So again, not my circus, not my monkeys, means that typically the cloud vendor, very happy to sell you a Java 8 instance and leave that running forever, which is great if you want to stick with Java 8 forever. But if you want to move to Java 10, Java 11, as a matter of fact, just a curiosity question, because this came to mind because of an email thread I happened to watch. How many people are using some of the Docker Java images that are out there for Java 8? Show of hands. Yeah, it turns out that a number of those are not actually running blessed OpenJDK builds. They're running interim builds. Did you know that? Did you even go back and look to see what version you were running? Sometimes that matters, particularly if you want to make the jump from Java 10 to 11 to 12 to 13. What build number actually is the blessed version? Because remember, anybody and their brother can spin up a Docker image. And in this case, this is an image that was coming out of, I think it was the Debian distribution, that said, oh yeah, we have a Debian Java image, and it's like a point release that was actually not ever released by OpenJDK as an officially blessed version. Gil Tene from Azul was bringing this. He calls it Mystery Meat Java. Now, one of the nice things about cloud is if there's a new thing, you can get a hold of it really, really easily, right? You know, all I got to do is spin up the right Docker container and boom, I have that thing. I'm now running whatever. Great, awesome. What else do you need to support that? What sort of monitoring tools, what sort of management tools, what sort of upgrading, versioning, et cetera, will the cloud provider provide? The cloud providers are generally going to be very good about providing blessed instances of things that have been demonstrated to be useful to the mainstream, but they're not always going to be super good about making sure that they have all of the latest and greatest, or that the latest and greatest is blessed and debugged and monitored and manageable, et cetera, et cetera, et cetera. The other thing, debugging, believe it or not, you will often want to get beyond system.out.println. Nobody's laughing at that. That's a little disturbing. If you know how, you can just attach to the cloud via the same kind of remote attach procedures that you use for debugging your code on another process on the machine, right? It's just literally pointing it at this particular port. Oh, that's right. I need to know the IP address and the port number of that particular instance in order to be able to hit that, which is going to be very difficult if I don't know the IP address for the machine up in the cloud. Now, I grant you, nobody should ever be debugging production. And we, all of us, when we first become debuggers, we solemnly stand in front of the programmer's board and we swear that we will never debug in production, right? None of you have ever done this, right? Right? Liars, all of you. We've all done it because it needed to be done, because your boss came down and said, oh my God, it's broken, and dragged you off and said, look, it's broken, fix it. And you don't want to tell your boss no, because typically the next words he has for you are you're fired. So you have to fix it in production in some way. How are you going to attach the debugger to a cloud instance if you don't know the machine, you don't have an IP address, and you're not even sure if that port is available through the firewall? Do you have the ability to open that port through the firewall? Or are you just going to be pouring through miles and miles and miles of log files, hoping that the bug will leap out at you and say, here's the bug. Here I am, this is what you do to fix me. Has anybody ever had that happen, by the way? Because I've never had that happen. I've never had a bug jump out and say, please fix me. So a couple of things to rip through the next set of slides is to just give you, again, basic overview. Part of this is to just, if you've not seen some of these cloud providers, to just give you an overview, and partly to prove that they are, in fact, very, very homogeneous. And one of the things that I will frequently do, you know, if I'm actually trying to do a deeper dive comparison, is I will bring up the home pages of these various applications. Let's see if I can get. Yeah, there we go. There's our friend Google. All right. Okay. And then if we want to log in here, and this is, nobody look. Never mind. You get the point. The better thing to do, hey, go away. I told you to go away. There we go. The better thing to do in many respects, if you're going to explore the whole cloud space, go fire up the AWS homepage. Every time you do this, there's something new waiting for you. Do the same for Azure, do the same for Google Cloud. They are constantly releasing new products, in many cases at a speed faster than anything you could possibly imagine. I mean, literally, I have seen services show up, a new one every day, just because I happen to be tracking it on a day-by-day basis because I was getting ready to do an AWS talk. And literally every day there was a new service listed over a span of about a week. It was actually quite disturbing. I finally gave up trying to have a comprehensive list of all of the services that AWS offers. Ditto for Azure, ditto for Google. They generally provide the same stuff as what we see with the big three. So Amazon, Google, and Microsoft are all pretty straightforward. Collection of services, we have compute and networking, we have storage and content. S3, by the way, is actually getting a radical shift. They're not going to let you identify items inside the buckets anymore. So, using a URL, I mean. So all those people who built their websites on top of S3 are actually going to have to figure out some way of adjusting for that. I don't know why Amazon is making that change, but they announced this about 2 or 3 weeks ago, if I remember right. They may back away from it, I'm not sure. Databases, they've got a ton. Analytics, they've got a ton. The app services, message queuing, notifications, et cetera, allowing us to organize and orchestrate, et cetera. Deployment services, management services, and again, to reinforce the point, it's constantly changing. Matter of fact, there may even be a new category on there. So let's see, yeah, machine learning should be on that list because that's becoming a category that they're very rapidly growing into. And Amazon, like the other cloud players, is rapidly growing so their support for Docker containers. That seems to be the one thing that all the clouds are really agreeing on, is that if you can put something into a Docker image, we can run it for you, and we can put all sorts of services around it and so forth. Amazon has a bunch of different SDKs. Again, most of this continues to change. They do have some preferential treatment in some respects, meaning the .NET SDK doesn't get quite as much love as the Java SDK does, or the Ruby SDK. But for the most part, Amazon, the SDKs will have the same features available to them. Particularly the command line tool, they will make sure that that is up to date with anything that can be deployed via the portal. Usually the command line tool can also update it as well. And that's the URL that I was going to try to navigate to if you want to go look at that full list of everything that Amazon offers. It will scroll off the page. As a matter of fact, I think it's up to 2 full screen pages now, possibly 3. Azure is much the same story. This is Microsoft's implementation. They support all of the same basic things. They have, again, a portal, same story, different company. Compute, data, networking, development services. This is one of the things that Microsoft has stressed as a difference maker between them and the others, in that if you want to actually write code, they have a code IDE right there waiting for you in the cloud. Literally go fire up your Chromebook, go log on to Azure, and start writing in Visual Studio in the cloud. A lot of their work actually around Visual Studio Code, the text editor, has gone to support their online IDE. So winning, losing, I don't know, it's your choice. They also have some strong mobile services. Their notification system, they've actually spent a lot of time investing in. There are a lot of companies that are using that to great effect. Data, big compute, that's kind of where their machine learning stuff is starting to slot in as well. And in many cases, Microsoft today, the Microsoft of 2019, is very different than the Microsoft of 2009. Microsoft is actually very willing to embrace things that are being built outside of Microsoft. Case in point, in the machine learning space, there are a number of Microsoft AI advocates that are actually talking about TensorFlow, which was created well outside of the Microsoft space over at Google, if I'm not mistaken. So this is definitely not your father's Microsoft, as they say. Again, the list is constantly changing. Microsoft is slowly growing their support for Docker. They've recently thrown their weight in behind Kubernetes. They are continuing to revamp and revise this story. Again, Microsoft has a whole slew of SDKs. Not surprisingly, the .NET SDK typically gets the best love from them, but they've also shown a recent resurgent interest in Java. There are actually some folks at Microsoft who are going to Java conferences specifically to try to talk about what do we not do well and bring that message back, because they really do want to be comfortable for Java developers. And again, that URL will give you the full list of all the Azure documentation that's available. Microsoft, unfortunately, has a tendency to rearrange their documentation periodically. So that URL hopefully will be good for a while. But if it doesn't, don't blame me, blame the docs team at Microsoft. Google, of course, Google Cloud Platform. Google knows how to scale. So they were actually first to the whole cloud space. But because GCP was actually built more around this serverless, as we call it now, model, the idea that I don't know the machine on which I'm running, they actually didn't support the whole lift and shift for quite a while. And unfortunately, that hurt them in some of their messaging. Now, since that time, Google has come out and said, oh yeah, we are by far and away more reliable than the other two. Microsoft has said the same thing. Amazon has said the same thing. Right now, Google is considered probably the number 3 cloud provider in the space. They have some really interesting stuff going on. But as you can see, a lot of it is the same stuff that we see in AWS and Azure as well. Big data, networking, some of the services, management. They've also got some AI stuff. They've got SDKs for a variety of the different programming languages. Yeah, this is really the same story for all 3 of these big boys. Now, there are some smaller vendors to consider. One is, I mentioned earlier, Force.com. This is the Salesforce platform, and they were really pushing this for a while. They actually acquired Heroku as a part of this to push the idea that if you are doing something with Salesforce, you then want to actually run code on Force.com because it will be easier for people to be able to connect your CRM stuff to whatever applications you're building. Force.com is an interesting vendor platform. I am not encouraging everybody to run out and start using it. I'm encouraging you to take a look at it, particularly if your company uses Salesforce CRM. It uses a bastardized form of Java as a language they call Apex. And it's a language that, you know, your mother may not even love because it's quirky, it's interesting. Of course, Heroku is one of the original developer platform as a service implementations, and a lot of people still use it. Salesforce has turned out to be a pretty good steward of Heroku, so that's always a possibility. The list of plugins for Heroku continues to grow, which is good. They have a platform API which allows us to do a variety of things with Heroku, including some of that provisioning stuff that we talked about earlier. And if you're a .NET developer, yeah, I know, most of this is going to be a Java shop, but a similar platform to Heroku is a platform called App Harbor. They're basically Heroku, but they're more .NET-centered rather than Java-centered. So if you've got some unlucky colleagues who are working in .NET, and I say that as somebody who actually loves .NET a lot, App Harbor is basically a Heroku equivalent, again, with a similar list of plugins and APIs. Now, the last one I want to point you at is actually what we would refer to as a full stack cloud. Meteor is actually the company behind Meteor JS, which is effectively an all JavaScript stack for doing both the client and the server, to the point where you just write code and the Meteor bits will decide which of that needs to go to the client and which of that needs to go to the server. It's quite an audacious attempt, and they built their own cloud in order to allow people to simply deploy Meteor code without having to worry about the intricacies of Node and NPM and so forth. Now, they later on just figured out that they needed to support Node and NPM, but the key idea here is that you write code, you develop it in that one language, it runs both client and server side. Again, they break it out as according, and you deploy it to their website, deploy it to their cloud, and it just works. They have the database running, it's a Mongo instance. They have the server running, it's a Node instance. They have your client of choice. They built their own, or I think you can use Angular. And you get all of this stuff. Now, what do you not get? Well, fundamentally, you don't get all of the things you would normally associate with having full control over the entire stack. So, for example, if I want to debug this, if I want to try to attach a debugger, et cetera, I have to figure out how Meteor wants to do it, and how big are they, how reliable are they. Technically, I think they're running on top of AWS. But this, from a developer's perspective, is the absolute end game with respect to cloud. I write code using their stack. I say Meteor push, boom. It goes, it's gone, it's ready to run. To some people, that's a good thing. To other people, that's a terrible thing. The last one, sorry, I forgot. I also have Parse in here, which actually went bankrupt. Well, I shouldn't say bankrupt. They got bought by Facebook, and then they got shut down. But Parse actually released all of their code into the open source environment, so you can actually go grab the code off of GitHub and run this on an instance in your own cloud, or several of the cloud vendors actually have Parse server instances up and running, ready to go. They give you a basic JSON storage, they give you some server-side JavaScript execution, and it's quite the nice model for getting started. A lot of my students, when they were building applications for my mobile development class, would reach for Parse and use it. And so as long as you're willing to do a certain amount of maintenance and care over the Parse bits, you can actually continue to use it to this day. The cloud thing is clearly not going away. The cloud thing is clearly something that all of us need to pay attention to. There is definitely an understanding that for any new application, if you're not putting it into the cloud, you'd better have a good explanation why. But there are good reasons not to run in the cloud, and there are a whole host of concerns that you have whenever you start thinking about the cloud and how you're going to approach it and how you're going to address it. If you haven't started thinking about those, now is a good time, much better than after it becomes a problem. Peace.